both sides, you still get equality. They show you that with 6 equals 6, taking 6 times 3 on both sides, and you still get 18, 2 equal sides. Same thing with division. If you start with 8 equals 8 and divide both sides by 4, you still have an equal statement, 2 equals 2. So let's see how we can use this information to help us solve some one-step equations with addition, or multiplication and division. So you still, first of all, want to figure out what's happening to your variable. So if I'm looking at A, K is being divided by -5. And in order to solve for K, I have to do the opposite, or the inverse of dividing by -5, which means multiply by -5. And I want to do that to both sides. Okay, so what does this look like? Technically, the -5 cancels out with the divide by -5. So the multiply cancels out with the division. If I set it up like this, you don't have to do this. I'm just going to show you this so you can see what happens here. I could put -5 over 1. And what would happen is I could multiply K times -5 on top, and I would get -5K. And then -5 times 1 on the bottom. And what ends up happening here is we've got a -5 over a -5. Well, that's just 1. Those cancel each other. You're left with 1K. And that's what we want. Remember, we want to isolate that variable. So whenever you see a variable being divided by something, multiplication will cancel out that division. And you do not need to show that long procedure that I just showed you. I'm just showing you why it comes out that way. So -5 multiplied will cancel out with a division by -5. We're left with just K, or 1K. And remember that I had to do -5 times -4 on the other side, which is positive 20. And you can always check, you plug in your variable back in for K. If you do 20 divided by -5, you do get -4. So you get the right answer there. Letter B, I think it's the exact same procedure. I would multiply both sides here by 3. Since M is being divided by 3. And that would cancel, M equals 4.5. There we go. Okay. So that's what's happening there when we're dividing by a variable, or variables being divided by something. We multiply to solve for it. If a variable is being multiplied by something, we're going to divide in order to figure out what the answer is. So 7 times x, what's happening to x? Well, I'm multiplying by 7, so I want to divide by 7 on both sides. 7 divided by 7 is 1, so we're left with just 1x, or just x equals 56 divided by 7, x equals 8. Alright? The only other thing that B is showing you is that sometimes you can divide by negatives. W is being multiplied by -2. So I would divide by -2 on both sides. W equals -6.5 or 6.5. There we go. So keeping track of those negatives will also be ideal and important. Okay, lastly, we've got A and B here, some fractions. Now, when you look at a problem like A, you've got 5/9 times B, and we're trying to solve for B. So normally, if that was a regular integer, we would just take that integer, we would divide by it. So same thing with the fraction, we're going to divide both sides by 5/9, which looks kind of funny when you do it like this. Because what you've seen in the past is 35 divided by 5/9. That's what is going on right here. 35 divided by 5/9. So you've seen it in a little more horizontal fashion. Now remember, when you take something divided by a fraction, you can turn it into multiplication by using the inverse. So 35, I'm going to put it over 1 times, and we do the reciprocal, 9/5. And then that is how we divide fractions. So that's bringing in some old knowledge here for this. Now, if you recognize that you have something being multiplied by a fraction, and you know you have to divide by that fraction to solve, well, you can just right away say, well, I'm just going to multiply by the reciprocal right away. Because I know that dividing by a fraction is the same thing as multiplying by its reciprocal. And what ends up happening then is, you can see 9 and 9 cancel out, you get 1 and 1. talk about